The food on your plate right now was engineered in a laboratory by scientists whose job was to make sure you couldn't stop eating it. They succeeded beyond imagination. This is food engineering, a scientific discipline. A 1970s discovery changed the food industry overnight. It's called the Bliss Point. Understand it, and you'll never look at crisps, Coke, or fast food the same way again. Here's what nobody in the food industry wants you to know. The reason you reach for more when you said you'd stop, why a single biscuit becomes the whole packet, why you're hungry again 2 hours after a fast food meal. None of that is weakness, poor discipline, or your fault. It's the predictable, engineered outcome designed to override your body's stop signal. Today, we'll follow the science, to the lab where it started, through the neuroscience of what it does to your brain, and out the other side with something genuinely useful. Let's start at the beginning. The year is 1972. Howard Moskowitz, a market researcher, faces a problem. Pepsi hired him to find the perfect aspartame concentration. Too little sweetness, people don't like it. Too much, it becomes cloying, artificial, unpleasant. Moskowitz does what any good scientist does. He creates 20 different versions of the drink, with 20 different sweetness levels. He gives them 2 test subjects. He records the ratings. And he expects to find a simple answer, a peak, on a graph. He finds no such point. What Moskowitz discovers instead is something much stranger and much more useful to the food industry. He finds that for complex foods, there is no single perfect point. Instead, there are clusters. Different groups of people peak at different combinations. But here's where it gets interesting. When Moskowitz combines this finding with work on salt and fat, he finds something that changes everything. He finds that the human brain has a preference ceiling for simple flavors. You can have too much sugar, too much salt, too much fat, but you cannot reach the ceiling for all 3 simultaneously. Combine them in the right ratio, and something extraordinary happens. The brain's stop-eating signal is suppressed indefinitely. This combination became known as the Bliss Point, and Moskowitz didn't keep his discovery to himself. He sold it to everyone. By the late 1970s and 1980s, Moskowitz was a consultant to Campbell's Soup, General Foods, Kraft, and dozens of other major food manufacturers. His methodology became the foundational model of modern processed food development. Every major snack brand, fast food chain, soft drink manufacturer, all of them, at some point, have run their products through this process. They weren't just trying to make food that tasted good. They were engineering food that your brain literally could not say no to. Now let's go inside the science. Because understanding exactly what fat, salt, and sugar do to your brain individually is what makes the combined effect so alarming. Let's take them one at a time. Fat. Fat triggers the release of dopamine in the nucleus accumbens. This is the same brain region activated by gambling wins, social praise, and yes, addictive substances. Fat also activates the opioid system. Your brain releases natural opioid-like compounds, producing a mild but real sense of pleasure and calm. But here's the critical detail. Fat delivers flavor without friction. It coats your mouth. It slows chewing, and because it has very little flavor of its own, it acts as a carrier, amplifying every other flavor dissolved in it. Fat makes everything taste more like itself. Salt. Salt is not just a flavor. It's a flavor enhancer, suppressor, and texture modifier. It suppresses bitterness, which is why salt in chocolate makes it taste more intensely chocolatey, not salty. It enhances sweetness. It amplifies umami. It makes food more three-dimensional in your mouth. And critically, salt triggers thirst. Thirst that, in modern contexts, is most conveniently resolved by a soft drink, which contains sugar, which is why crisps and fizzy drinks became the most profitable pairing. That was not an accident. But there's a deeper effect. Salt slows the brain's habituation to flavor. Normally, as you eat the same food repeatedly, the pleasure response decreases. Salt disrupts this process. It keeps the flavor feeling fresh further into the eating session than it should. Sugar. Sugar is the most studied ingredient in addiction literature. Here is what the science agrees on. Sugar triggers a dopamine response. It activates reward pathways. It produces a fast energy spike, followed by a crash that the body interprets as an energy deficit, which triggers cravings. And it has a high incentive salience, meaning your brain assigns it motivational importance, making it hard to ignore. Is it technically addictive in the clinical sense? Scientists still debate the definition. But here's what is not debated. Food companies add sugar to products where you would never expect it, not to make them sweet, but to trigger the reward pathway subthreshold. Below your conscious awareness of sweetness, just enough dopamine to make you feel slightly, unaccountably better when you eat. Check the ingredients label on bread, on pasta sauce, on salad dressing, on processed ham. You will find sugar in all of them. Not because they need to be sweet, because it makes you feel better about eating them without you knowing why. Now we need to talk about one of the most brilliant and sinister pieces of food engineering ever developed. It's called vanishing caloric density. And it's the reason Cheetos, specifically, became one of the best-selling snack foods in history. Food engineers discovered that the speed at which a food dissolves in your mouth directly determines your brain's calorie count for that food. If food is dense, if it requires sustained chewing, your brain accurately estimates its caloric content and registers satisfaction accordingly. But if food dissolves quickly, if it melts away in your mouth within seconds, your brain receives an incomplete signal. It registers, "I'm eating." But before it can complete the calculation of how much the food is gone, the technical term is oral processing time. And food engineers spent years systematically reducing it. The result is a product that registers in your mouth as substantial, but dissolves before your brain can fully account for it. Your calorie tracking system believes you've eaten almost nothing, so it tells you to eat more. This is not a theoretical risk. This is measurable. A standard serving of Cheetos contains 150 calories. But studies show that people eating Cheetos from a large bag systematically underestimate their consumption by up to 40%. They ate it. They just didn't feel like they did. Let's go deeper. Because what's happening in your brain when you eat engineered food goes beyond simple pleasure. Your brain's reward system evolved to motivate you toward behaviors essential for survival: food, water, social connection, reproduction. Each of these triggers a dopamine response that makes you feel good and motivates you to repeat the behavior. The problem is, this system was calibrated for a world that no longer exists. A world where food was scarce, physically demanding to obtain, and nutritionally variable. In that world, a highly palatable food was so rare that going oolin when you found it made complete evolutionary sense. Ultra-processed food is a cheat code for this system. It delivers a level of dopamine stimulation that no natural food could produce. The combination of precise sweetness, saltiness, fat content, and dissolving texture produces a reward signal so strong that it competes directly with your rational decision-making. Not metaphorically, in brain imaging studies, eating highly palatable processed food and receiving a monetary reward produce overlapping activation patterns. Here is where it becomes clinically significant. Normal satiation works like this. As you eat, your gut releases hormones that signal fullness to your brain. Your brain reduces the reward signal. You feel satisfied. You stop eating. This is a sophisticated multi-stage feedback system that took millions of years to evolve. Ultra-processed food partially bypasses it. Here's how. The combination of fat, sugar, and dissolving texture produces rapid reward before the satiation signal can complete its journey, a lag of approximately 20 minutes. In 20 minutes of eating highly palatable food, you can consume a significant portion of an entire day's calories. Before the signal arrives, and by the time it does arrive, your dopamine baseline has shifted. Your brain has been stimulated to a level that ordinary food cannot match. Studies with rats, given extended access to ultra-processed food, show changes in dopamine receptor density, meaning they require more stimulation to achieve the same reward response. This is the same mechanism seen in substance tolerance. The food doesn't just make you eat more today, it makes ordinary food less satisfying tomorrow. So, is this hopeless? No, and I want to be very clear about why. Understanding the mechanism is not the same as being controlled by it. The research that revealed how engineered food affects the brain also revealed what disrupts those effects. And it turns out the interventions are simpler than you'd think. Not easy, but simple. First, awareness changes behavior, but only specific awareness. Knowing exactly how it does, this produces a significantly larger effect, which is why we went deep today instead of staying surface level. Second, food environment matters more than willpower. Studies show that the single most effective intervention for reducing ultra-processed food consumption is not motivation or discipline, it's friction. Putting the biscuits in a cupboard instead of on the counter, not buying crisps in large bags. Not keeping sugary drinks in the house. Every piece of additional effort between you and the food reduces consumption by measurable amounts. Your willpower is a limited resource. Your environment is not. Third, whole foods. Foods with complex fiber matrices and intact cellular structure engage the oral processing system properly. They require more chewing. They deliver their calories more slowly. They give your satiation system time to respond. They are not more virtuous. They are just biomechanically more compatible with the system that evolved before food engineers existed. You don't have to be perfect, you just have to make the default easier. The food on your plate was engineered. The cravings you feel are real, but they were induced. The difficulty stopping is biological, not personal. You now know what billions of dollars of food science and decades of research have tried very hard to keep quiet. What you do with that is up to you. If this changed how you see something you thought you understood, subscribe, because there's a lot more where that came from. And drop in the comments, which food do you find hardest to stop eating?